Good morning, students. Thank you very much, students, for clicking on my video. I'm your Nagini ma'am, chemistry mentor. In today's session, I'm going to discuss about the names of cationic complexes, students. This is the topic from coordination compounds, 12th class, Nana, second PUC topic. So, in the last videos, I discussed you some rules, Nana, IUPAC rules. And next, names of anionic complexes video also I discussed, Nana. Okay, now if you want to, please once you go through that video. Okay, here I am going to discuss about only names of cationic complexes. Okay, now so if the given complex is a cationic complex or anionic complex, how to identify, students? In any salt, Nana, just you have to remember first cation will be there, second place anion will be there. Understanding, students? Just suppose I am taking NaCl salt. See here, NaCl salt I am taking. In NaCl salt, sodium is the cation, Na plus Cl, it is dissociated into Na plus and Cl minus. So it is cation, and chlorine is anion, correct? Cl minus ion is anion. So in any salt, if you take, students, first cation will be there, next anion will be there, like that only. See here, this is the square bracket part, this is first part, this is the second part. First part, second part, first part, second part. Are you understanding? So in two parts, here this is the first, this is the second. First one is already, first one is which one, students? Cation, always. Second one is anion. Now see here, this is the square bracket part, this is the cation. So this is the first place, it is in the first place, square bracket part. That's it is the cation, it is the anion. Are you understanding, students? Understanding? It is the cation, it is the anion. Cation, anion, cation, anion. Are you clear this one? Understood, students? I will take the, that's why here in the cationic place, in the cation place, square bracket part is there, complex is there. So that's why we are calling as these complexes are cationic complexes. Are you understanding? In the cation place, in cation place, square bracket part is there. This is cation, anion, cation, anion, cation, anion, cation, anion. Clear? So in the cation place, complex is there, square bracket part is there. That is called the cationic complex. Understanding, students? That's it. These are all the examples of cationic complexes. How to write the name of the cationic complexes. Now I'm going to discuss you, students. Understanding? So one example, students, anionic complex KAgCN, KAgCN twice. Now see this complex, students, here. Potassium first place, for potassium is there. This is the second part. This is the first part, second part. This is cation, this is anion. Are you understanding? This is cation, this is anion. So that's it. The anion place square bracket part is there. That's why it is anionic complex. In the cation place square bracket part is there. It is the cationic complex. Understanding, students? So how to write the name of the cationic complex? When you are writing the names of cationic complexes, students, cationic complexes, so first you have to write the name of the cation. So this is the order you have to follow, students. First cations are named first, cation name should write first. Next, second one is in the coordination entity, students. In the coordination entity, if suppose it is cation or it is anion, first you have to what is the order you have to follow? In first you have to write always cation name, Nana. Next one, what you have to write? In after that, number in the coordination zone, in coordination zone, or in the square bracket part. Are you clear? In the square bracket part, first what you have to write, students? First, number of ligands, number of ligands should write. Next one, name of the ligand. Clear? Name of ligand should write, Nana. Next one, name of the central atom, name of the metal should write, name of the central metal atom, name of the central metal atom. Later, you have to write oxidation number of the central metal atom. Clear? Oxidation number of central metal atom. This is the order you have to follow, students, when you are writing the name of coordination complexes. Clear? So first you have to write cation name, Nana. Next, Nana, in the coordination zone, number of ligands. Next, name of the ligand, name of the central atom, oxidation number of the central atom. This is the order you have to follow, Nana. you have to follow. Now see students, so first one is, this is the complex, cationic complex. So in the cation place square bracket part is there, it is the cationic complex. How to write students? So if first in the cation place only square bracket part is there, coordination zone. So first, what is the order we have to follow in the coordination zone? Number of ligands, first we have to write. How many ligands are there? 6 ligands are. This is the central metal atom, these are the ligands. Are you clear? So this is the central metal atom, this is the ligand run. How many ligands are there? Number of ligands, 6 are there. So that's a what, how to write name? Hexa. 6 there means what is the prefix we have to use? Hexa, nana. Okay na? So hexa we have to use hexa. Okay, NH3 is a neutral ligand, amine. Clear? Hexa, amine. Next one, this is PT, platinum. Now what you have to write? Name of the ligand, number of ligands over. Next to name of the ligand also over, amine. Next one, name of the central atom. Name of the central atom, PT is there, PT. So when you are writing the name of the central metal atom, students, if the coordination zone is it is cationic complex, then you have to write name as it is, students. Metal name as it is you should write. Okay now, so that means platinum only, copper only. Are you understanding? Copper only. Clear? So hexa, amine, this is platinum. Okay, so platinum as it is you should write. You should not add any 8. Only when you have to add 8, if it is anionic complex, if the coordination zone is anionic complex, then you have to add 8 none. Okay na? You have to add 8 to the name, to the name of the metal atom. Okay now, so here, but you no need to add anything, just central metal atom name, element. Okay, element name as it is you should write, platinum. Clear? Platinum. And next, oxidation number you should write. Next, this is completed. Now anion name. This, now see students, this is cation name first. Cations are named first. Completed. Cation name completed. In the coordination zone we have to follow. This is the cation. In the coordination zone, first how to start the name? Number of ligand, name of the ligand. Next, name of the central atom. Next, oxidation number of the central atom. So completed. Okay, next one, this is chloride. Here 4 chlorines are there, means tetrachloride you should not write, only just chloride you should write, amma. Are you clear? Chloride. Okay, chloride, sulfate, nitrate. Okay now, chlorine, chloride. Okay, this is chloride. Understanding? How many are there? You should not write, just you have to write the element name only. Chloride, sulfate, nitrate, that much only. Now we have to find the oxidation number of the platinum. Okay now, how to find it, students? Oxidation number, NH3 is a neutral ligand na, 0. Okay, chlorine is a negative ligand, oxidation number is -1. -1 into 4, -4. Here 0. This is platinum 1. So total -4. -4 by 1. Platinum only 1. So -4 by 1 means that is oxidation number is how much, students? +4. Clear? +4. Understood, Nana? Here X plus, how to find it? Platinum we don't know, we have to find it. So, neutral ligands 0. Neutral ligand means oxidation number 0. 6 molecules are there, 6 into 0. 4 chlorines are there, 4 into -1 equal to 0. Then platinum -4 equal to 0. Platinum is equal to +4. Clear? +4. So directly we can write, no need to do this much calculation. So NH3 ammonia is a neutral ligand na, so that's here you have to take 0. Chlorine oxidation number -1. 4 chlorines are there, -1 into 4, -4. So this is platinum only 1 is there, -4 becomes +4 by 1 equal to +4. Completed. So here that oxidation number you have to write 4 in Roman number. Understanding? As a Roman number you have to write it. Now tell me, students, this name. Now see here only one type of ligands are there, but here different types of ligands are there. Water there, NH3 there. This water is neutral ligand, NH3 also neutral ligand. This is aqua, this is amine. Understanding? This is aqua, this is amine. Now how to write, students? Which is, now more than one ligands are there, means what you have to follow? Alphabetical order we have to follow. So this is aqua, this is amine. So which letter is coming first? This is A. First letter is same only. Then go to the second letter, students. This is aqua. I'm writing here aqua. This is amino. Now which is coming first, students? amine is coming first, correct? Which letter is coming first? Q is coming, or M only will come. So that's why this is tetraamine. Are you clear? How many are there? Number of ligands, 4 there. So that's why you have to write tetraamine. Okay, tetraamine completed. Now this one is tetraamine after di aqua. Next copper, as it is name copper. Next oxidation number of the central metal atom. This is the order I told you now. In coordination zone, number of ligands, name of the ligands, name of the central atom, and oxidation number completed. Now outside the square bracket part, sulfate SO4 is there, that you have to write sulfate. Calculate oxidation number, students. H2O. Here what is oxidation number? Water is neutral ligand 0, NH3 neutral ligand 0, sulfate oxidation number is -2. Clear? So then what you will get, students? Equal to +2. So that's why oxidation number is how much, Nana? +2. Clear? This is -2. If it is going to that side equal to that side, then what will happen? It becomes positive. So +2. Now tell me this name. Tell me this name, students. This is ene is there. Ene is nothing but it is a neutral ligand, ethane 1 comma 2 diamine nana. So in I told you already in rules I explained. Okay, now some ligands they have the prefixes di, tri. Okay, now and tri, next tetra. These prefixes, if suppose some ligands they have in their names, students, you have to use the other prefixes. Those are bis, tris, tetrakis, etc. So instead of 2 we have to use bis nana. This is chlorido. This is ethane 1 comma 2 diamine. Are you clear? So which is coming first? This is ethane. First letter is E. This is chlorido. First letter is C. So which is coming first? Alphabetical order. Chlorine will come. So how many chlorines are there? Di are there. So dichlorido completed. Now this is which one? This is not diene, you should not write, students. 2 is nothing but here bis we have to use the prefix. Okay, nama. So because in eno in ethane 1 comma 2 diamine, ethane 1 comma 2 diamine. Okay, na, that means already di is there, understanding? So prefix already there in its name only, this prefix is there. That's why we are using, instead of 2 bis, we should not use di, because already in name di is there. Okay, so that's why here instead of 2 what you have to use, nana? Bis, we have to use bis. And in full form you have to write ethane 1 comma 2 diamine. Okay, 1 comma 2 diamine, bracket close, nana. After that, central metal atom name chromium. Next, oxidation number. Next, here outside the bracket nitrate group is there, nitrate. Clear? Now find oxidation number, students. Chlorine oxidation number -1. Okay, now here 2 is there, so -2. Here ene is a neutral ligand 0, NO3 -1. Okay, -2 -1, how much, students? -3. It is going to that side, means +3. So what is the oxidation number? +3. Clear? Oxidation number is +3. Now see here, next compound, dibromido. See this one. Here bromido, this is ene, which is coming first? Alphabetical order, this is coming first. So that's what you have to write. Dibromido. This is bis, ethane 1 comma 2 diamine, bracket close, cobalt. Oxidation number should write. Next, chloride. Clear? This is chloride. Outside bracket chlorine is there, chloride. Now calculate oxidation number. Bromine oxidation number -1. 2 atoms are there, so that's why -2. E neutral ligand, chlorine -1. So -2 -1 -3, that means +3 you will get the oxidation number. Okay, now see, students, next one, next example. Mn in tri-Cl3. So here 3 is there. So that's what you have to use. Tris we have to use. Clear? Tris, ethane 1 comma 2 diamine, manganese. As it is, you should write manganese. Clear? Tris, ethane 1 comma 2 diamine, manganese, oxidation number, chloride. Okay, now, madam, here 3 chlorines are there. We should write trichloride. No, just directly you have to write chloride. That much only. Dichloride, trichloride. We should not write. Clear? Outside the square bracket. Now, what is the oxidation number? Calculate, students, here. En is neutral ligand. Chlorine is -1. 3 atoms are there. -3. That's why this oxidation number is +3. So that is going to that side. +3, it becomes +3. Now see, students, next example lana PTCl NO2 NH3 4 SO4. Okay na? Now see, students, this example how to write name. Here three different ligands are there. One is chlorine, nitrite to ammonia. Are you understanding? So three are there. This is chlorido, this is nitrito, this is amine. Okay, now this is amine. Which is coming first? This is amine. I am writing here amine. This is nitrito. This is chlorido. Which letter is coming first? Alphabetical order. A, first letter. Next C will come. Next nitrogen will come. N. So first amine name we should write tetra. 4 are there. So tetra amine. Clear? Next chlorine should write. How many are there? Only one chlorine. Chlorido. Tetra amine chlorido. Clear? Chlorido. Next nitrito. Okay. Nitrito. Okay, nitrito. Next is name of the central metal atom. So till here ligands names completed. Number of ligands, name of the ligands complete. Name of the central atom. Name of the central atom platinum. Okay, platinum. Next oxidation number of the tell me, students, oxidation number of the platinum you should write. What is the oxidation number of platinum, Nana? Platinum oxidation number, you have to find it. See here how to find it.